Hello everyone, this is Sukruti Joshi from LG Institute of Engineering and Technology, Ahmedabad. I am going to take the video lecture series on chemistry. The subject code for chemistry is 311001. In the previous sessions of this particular subject, we have started our chapter number 4's another part, which is rubbers. Chapter number 4 can be divided into three subparts: polymers, rubbers and fibers. So here we have taken that what is a rubber. We all know that rubber can be of two types, a synthetic one and a natural one. Natural rubber is generally obtained through the tree, but synthetic rubber can be manufactured. Can be manufactured in industry, in laboratory, in any kind of factory. It is basically a man-made polymer. Now, in our previous session, we have studied about the natural rubber. And we have seen the vulcanization of that natural rubber. Why we need to do the vulcanization and what is the need of it? So all these things we have studied in our previous session. In this particular session, we will take a look on synthetic rubber. This is the second type of rubber, that is synthetic rubber. Now, synthetic rubbers are commercially synthesized rubbers, which are known as neoprene rubbers also. If you remember, in natural rubber, when we deal with the natural rubber, the monomer of natural rubber is isoprene. But here, it is also known as neoprene rubber. Now, the styrene rubber or Buna-S rubber. Generally, when we deal with this, so the synthetic rubber is known as the styrene or Buna-S rubber. Why is it so? Because it contains copolymer, or it is a copolymer of butadiene, which is 75% of butadiene is added, and styrene is added in 24%. Now hence the name, that is Bu, comes from butadiene, Na comes from the symbol Na for sodium, and S came from the styrene. In this way it becomes Buna-S rubber or styrene rubber. Okay. So this Buna-S rubber is the first synthetic rubber developed during the Second World War by US, that is United States, in order to overcome the scarcity of the natural rubber, and it is prepared by the copolymerization method of butadiene and styrene rubber. Both of these are combined together to form the Buna-S rubber. Okay. Now let's take a look on the mechanism, on the process of how the Buna-S rubber can be made. So here, as you can see in the image, what we will have is, first one we have, that is butadiene. Okay. Another one we have is the styrene. Both of this combines together through copolymerization method. Now what happens? The whole long chain, above that the chain is been formed, right? The whole long chain of Buna-S rubber can be formed. As you can see in the image, it contains n number of Buna-S monomers. Okay? Which are the properties of such kind of synthetic rubber? So if we take a look on it, it is a strong and a tough polymer, and it is a good electrical insulator. They are considered as a very good electrical insulator. If we talk about the applications, so as we all know that it's very tough, it's very strong in nature, so it is a very good it contains a very good mechanical strength. Because of it, they are widely used. So what we need to take a look at, the major application of styrene rubber is in manufacture of tires. Okay, it is used in footwear industry for making shoe soles and footwear components. It is also used for making the wires and cable. Even it can be used to manufacture insulators also. Okay, because of such kind of very good properties, they are widely used nowadays. That means we use less vulcanized rubbers, but we use actually a very high amount of such kind of synthetic rubbers. Now, our next topic is biodegradable polymer. So, what do you mean by biodegradable polymer? So, we all know that the polymer is non-biodegradable. That means they can live in the environment for a very long time. But if you want to prevent the environment, we have to make certain kind of particular polymer which can be sustainable for a longer time. So, biodegradable polymers are the polymers which can decompose under aerobic or anaerobic conditions, and as a result of the action of microorganisms or enzymes. Okay, the materials developed like starch, like cellulose and polyesters, they are considered as best biodegradable polymers. Okay, now some of the examples of biodegradable polymers are given below. The first one is poly 6 hydroxybutyrate CO6 or co-beta hydroxyvalerate, that is also known as PHBV, and another one which is nylon 2 nylon 6, not nylon 6:6, it's nylon 2,6. Okay, so let's take a look at them. First one, we will talk about poly beta hydroxybutyrate and co-beta hydroxyvalerate. So here PHBV is derived by combining 3-hydroxybutanoic acid and 3-hydroxypentanoic acid, in which monomers are cross-linked by the ester linkage. Okay, and because of it they becomes biodegradable. Now, when we talk about nylon 2:nylon 6, it is a polyamide copolymerization of glycine and aminocaproic acid. It combines two things, glycine and aminocaproic acid. Now, let's take a look on applications. We will take a look on applications of various polymers here. Okay, the first one that we will have here is PVC, also known as polyvinyl chloride. So PVC is generally used or highly utilized in making pipe, making wire coverings, in manufacturing of toys, bottles, door and window components. Similar way, it will be widely used in film and fabric coatings also. Now, another kind of polymer that we will take a look is polythene. Polythene's short form is PE. So here they are widely utilized in packaging or generally packaging applications like trays. They are used to manufacture trays, bottles for the milk and bottles for the fruit juices, etc. They are used in consumer goods garbage containers. They are manufactured to make these things. Housewares, ice boxes, manufacturing of the toys, etc. Likewise, they are utilized in fibers and textiles by manufacturing or utilized in manufacturing ropes, fishing and sport nets, that is sports nets, Nets for agricultural uses, to manufacture greenhouses, to manufacture certain kind of white house or a kind of typical green net for agriculture use. They are used in industrial and collaborative different kind of fabrics. They use to manufacture such kind of fabrics. In general, if I talk about the application of the polymers, so polymers are widely utilized. They are nowadays available everywhere. PVC, polyethylene or any other kind, PMMA or any other kind. It is widely used by all of us. From the water bottle to the bottle that is used in hospitals, everything is manufactured through polymers. This is because of their own properties, and that is advantageous properties. Let's move ahead. We have another two applications. First one is polypropylene, that is also known as PP, and another one is polystyrene, which is known as PS. So here, as you can see in the image, the polypropylene is generally used in automotive applications. It is widely used or mainly used in manufacturing automotive applications, household goods, then it is used in film, in manufacturing of the containers, it is used in manufacturing of the appliances, specifically kitchen appliances like mixtures, juicers, cutters, choppers, microwave, etc. Likewise, another one that we will have here is polystyrene. Polystyrene's short form is PS. So PS is used in refrigerators, air conditioners, microwaves, ovens, vacuum cleaners and blenders. That is hand blenders. Okay. It is used to manufacture many car parts, building walls, building roofing. Polystyrene is used for a wide range of medical applications, including tissue culture trays, test tubes and petri dishes. It is widely used to manufacture such kind of medical equipments. Next one that we will have here is PMMA. PMMA stands for polymethyl methacrylate. So this PMMA is used in glass roofing. It is widely used in window and door profiles, the transparent ones. PMMA sheets are used for designing LED lights. They are widely used in manufacturing the cockpit also. Okay. Next type is ABS. ABS stands for acrylonitrile butadiene styrene. This ABS is widely used in recorders, in protective helmets. They are very ideal for the luggage, for laptop cases and similar protective items. So they are used in manufacturing of the microscopic glass fibers also. Okay. Last but not the least is Gliptil. Gliptil is used in adherent paints, in lacquers, in building materials like asbestos and cement. Okay, this is all for this session. Next, we will see in our next session. Thank you so much, everyone.